Hello everyone, welcome to our YouTube channel. So today we are going to discuss about lasers. First of all, the full form of laser is light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. So here remember the term stimulated emission. So we'll be discussing about this later. So here Einstein was the first person who have proved lasing action theoretically. Okay. Then T.H. Myman was the first person who gave it practically. You got my point, right? Einstein was the first person who gave lasing action theoretically. Then T.H. Myman was the first person who gave it practically. So T.H. Myman, he invented ruby laser. It's a solid laser. So as I said, to remember this stimulated emission, we need to know about this, right? So before knowing about this stimulated emission, we need to know about absorption of radiation, spontaneous emission, and then stimulated emission. So we'll discuss absorption of radiation first. So here in absorption of radiation, we will be considering two energy levels, that is 1 and 2. This is E1, this is E2. E1 is also, this level is also known as lower energy state or ground state. In the same way, E2 is known as higher energy state or excited state. Excited state. So here in absorption of radiation, we will have two energy levels. We will consider two energy levels, that is E1 and E2. And first E1 is known as ground state or lower energy state, and E2 is called higher energy state or excited state. Now here in E1 state, I am considering an atom. So here to this atom, I am giving an energy of h nu photon. A photon energy of h nu is given. Photon energy h nu is given to this atom. So whenever we give this photon energy to this atom, the photon energy will be absorbed by this atom and then it will excite from E1 state to E2 state. So this way, E1, E2, as it is taking photon energy and it is getting excited to E2 state. It is represented like this. So this is about absorption of radiation. So absorption of radiation is nothing. Just will be considering two energy levels, that is E1, E2. First one, E1 is known as ground state or lower energy state. E2 is called higher or excited state. In E1 state, we will consider an atom. We will be giving a photon energy to this atom. This atom will absorb this photon energy and then it will move from E1 state to E2 state like this. Okay. This absorption of radiation can also be remembered like an equation. Just see here. So if I say atom as A, I am considering atom as A, plus I am giving photon energy h nu, and this is giving rise to A star. A star here is the excited atom. A is atom present in E1 state before excitation. Okay. H nu is the whatever photon energy we are giving to this atom. Got it, right? By simply remembering this equation, we can write about this absorption of radiation. So next we'll discuss about spontaneous emission. So in spontaneous emission also we will have two energy levels. So we will discuss it now. But before that, the atom which got excited to E2 state will once again come from E2 state to E1 state. So that is the reason we are involving two processes, that is spontaneous emission and stimulated emission. So now we'll know what is spontaneous emission. So this is spontaneous emission. As I said that atom got excited to E2 state in absorption of radiation process. We will have that image only here. I mean that diagram only will be drawing here. That is, we will consider two energy levels E1, E2. The atom got already excited to E2 state. Now here in spontaneous it has to come from E2 state to E1 state. But when it is coming from E2 state, E2 state to E1 state, what will happen? That is to be known. So I already said that this atom, whenever h nu energy is given, it got absorbed and then it got excited to E2 state, right? In the same way, when it is moving from E2 state to E1 state, the energy which has taken by this atom will be released. That is, the photon energy which the atom has taken will be released when it jumps from E2 state to E1 state. That is about spontaneous emission. So spontaneous emission is a random process. So it is a incoherent. What is incoherent? The wavelength and all the wave properties are different for different photons. So it is called as incoherent. Now see here, you have to know the lifetime of an atom in excited state. So the lifetime of atom in excited state is 10 to the power of minus 8 seconds. After it completes this 10 to the power of minus 8 seconds only, it will jump from E2 state to E1 state, releasing photon energy h nu, what it has taken before getting excited from E1 state to E2 state. Okay. So now the same equation will be represented. Just see here. So we are starting from here, right? A star. A star is excited atom, right? And then this will give rise to atom plus what is it releasing h nu. Okay. By remembering this equation, we can write spontaneous emission very easily. We'll have atom in excited state. It will complete 10 to the power of minus 8 seconds. Lifetime will be over. Then it will jump from E2 state to E1 state, giving rise to atom plus h nu photon energy. Now we'll discuss about stimulated emission. Stimulated emission is the principle of laser working. Okay. So we'll consider the absorption of radiation diagrams. That is, we'll have E1 state, E2 state, atom present in E1 state. We will give h nu energy to this atom. It will get excited from E1 state to E2 state. This is known in absorption of radiation, right? Now, as the atom is in excited state, I already said this atom will get excited from E1 to E2 by taking h nu energy, right? Now in stimulated emission, what we do is we will give extra energy to this atom. That is, h nu energy will be again given to this atom before it completes its lifetime. Before it completes its lifetime. Okay, got my point, right? The excited atom in stimulated emission will already have h nu energy, but before it completes its lifetime, we will again give h nu energy to this atom. So now when this atom, after completing its lifetime, when it moves from E2 state to E1 state, what happens is it will come down like this. The atom will come down like this, but it releases 2 photons. It releases 2 photons. Why is it releasing 2 photons? Because I said no, it will have h nu energy before only when it is getting excited from E1 to E2 state in absorption of radiation. Here we are again giving h nu energy as extra energy before it completes its lifetime. And you remember lifetime is 10 to the power of minus 8 seconds in E2 state. Okay. So that is the reason, as it is having double energy, when it is jumping from E2 state to E1 state, it is releasing 2 photons. Okay. This is about stimulated emission. So once again, in the stimulated emission process, we will consider the absorption of radiation only. We will have E1 state, E2 state. Atom will be present in E1 state. We will give h nu energy to this atom. This atom will absorb this energy and it will jump to E2 state. So it is already having h nu energy, right? Again, we are giving h nu energy to this atom before it completes its lifetime. And the lifetime is 10 to the power of minus 8 seconds. As it is having double energy, when it is jumping from E2 state to E1 state, it is releasing 2 photons like this. So this will, this will increase. If here we are having one atom, we are getting 2 photons. If there are 2 photons, we will get 4 atoms. 4 photons. If there are 3 atoms, we will get. So like this, it will, the multiplication of photons will increase like 2 power n. It is represented like 2 power n. N equal to 0, 1, 2, 3, so and so, like this. So the equation to remember stimulated emission is, as the atom is in excited state, we'll start from E2 state only, right? So the atom is already present in excited state. Again we are giving h nu energy to that excited atom. Then it is giving rise to atom plus 2 h nu. Because this atom is already having h nu, right? So after having h nu, already it will have h nu energy, and again we are giving h nu energy. So the photon energy is becoming double. So whenever it is coming from E2 state to E1 state, it is releasing an atom plus 2 photons. So this is the equation to remember stimulated emission. So I thought I can explain clearly about multiplication of photons. So that is the reason I have stopped and stimulated emission. So see here, as I said, one atom will release 2 photons. 2 photons. And these photons will again meet with 2 more atoms and it will release 1 photon, 1 atom. Here 2 atoms will be having, and this will release again like this. Now we have got 4, 2, 4, and here we'll have 4 atoms. Now each atom will release 2 photons. Now 4 plus 4, 8. Next we'll have 8 atoms. Then 8 atoms will release 2 photons. Like that we'll have 16. So the process will continue. So the formula for this is mentioned like this, 2 power n, where n equal to 1, 2, 3, so and so. Sorry, 0 also. 0, 1, 2, 3, so and so till capital N. That is n number of atoms.